Welcome back to this tutorial series about Pandas. In this video, we will take a look at importing and exporting data, some basic functions that are pretty useful, and pre-processing basics like slicing, Boolean indexing, or changing data. Let's dive right into it and start by importing some data. You will find that there are several different data formats, but for now we will focus on comma separated values, or CSV for short. And a helpful feature of Pandas is that you can just use the link to a file in order to access it. You don't have to download the file first and then import it into your Python environment. And after looking at the resulting object data, you might have the suspicion that it is a data frame. And you're correct in believing that. Now, we can use any data frame, usually after altering it, to export the data. And we can use any path on our machine. I would just drop this file into the same directory I'm working with right now. I have to set the index to false, otherwise shift some things around. We don't want that. To check if that really worked, we can just import the local file using the same function as above. And have a look at it. And voila, that should be the same data as before. There are several other functions that can be used in exactly the same manner for different file formats. You just replace CSV with the required format, for example, read JSON or read HTML. And for a complete overview of all the functions, you can have a look at the Pandas documentation. There, everything in the series and lots more is listed and explained. Now we can take a look at some basic functions that will help you to get an overview of the data you're working with. And let's remind ourselves of the data frame we've created in the first video, the marks. And we can take a look at the shape of the data frame. Simply by using the property shape. And this results in a tuple with two values, as you can see, where the first value represents the number of rows, and the second one the number of columns in our data frame. Another great function is tail, head. Let's start with head. It lets us take a look at the first few rows of the data frame. In this case, 2, as we specified. And if we don't specify the number of rows, that should be displayed and as defaults to 5. Yes, there's also the function tail, which just shows the last few rows. And for some more in-depth look at the data, we can use the describe function, which returns some statistical information about the data, such as the mean, standard deviation, some percentiles. And there's also the info function, which gives us some basic information about the shape of the data frame and its columns, as well as the memory usage. All right, the next part we want to focus on is accessing data and using the functions log and ilog. Let's start with ilog. Ilog, or index location, works the same as indexing a multidimensional list. As our data is two-dimensional in this case, there can only be 2 indices and returns the value located at that given index. Let's have a look at our data frame again. And for example, if we wanted to take a look at the first row, we could just do it like this, using ilog. Just the first index, and then everything that follows. The type of the resulting object is or should be a series. Yes, I just spelled it correctly. Yes, it's a series object. So we can index that one again. Let's have a look at the marks. And there we have the top left value of a data frame. The same can also be achieved much faster by just using indices like this. This also shows the top left, as it's the first entry of exit. Or we can use the log function, so a mix of those two, which takes the labels of the row and column we want to access. In this case, the label of our first of our rows is exactly the same as the index, as we didn't specify those, but that's a pretty useful tip to know. And another benefit of the log function is that it also takes Boolean arrays that have the same shape as the data frame or series, and this is called Boolean indexing. Say, for example, we only wanted to have those people that achieved marks higher than 80. First, we can see that indirectly by just this, comparing the marks column of a data frame, that number, which results in a series object with Boolean values, true or false, as you can see. And now we can index the data frame by the series, and the result is the data frame with only those rows for which the condition is true. This is useful in many cases, as you can imagine. And as the syntax for the comparisons is not the same as native Python, we will have a closer look at it. In this section especially, feel free to pause the video before the code is run and try to guess the output in order to get a better feel for the approach. Right, so we can negate a statement by setting brackets around the statement and a tilde character before it. We can also use the logical AND by, again, surrounding the cases by brackets and dividing them by the AND symbol. There's also the logical OR, which is used in the same way as the logical AND, just with the type character instead, and should result something different. Last but not least, we can also use the function isIn, which does exactly what you think it would. The function takes a list and returns true if the value is in that list. So we should only get 2 rows. And the last topic of this video is changing data using Pandas. You will get to know a few main operations you need to work with data frames efficiently. First, we want to add a column to our data frame. This can be simply done by indexing a new label and specifying the value or values. If we take a look at the result now, we can see that everyone did get an A. And suppose you want to give different grades to different people, we can just use a list and setting the grade column instead of a single value. And then you can also have a look at it. You can see that now Jack has a C. We can also add a row to our DataFrame in pretty much the same way. And we will use our knowledge from before and do it by working with the log function. This should have created a new row. Gem. Of course, we can also change a single value. This is done the same way as above, just with indexing already existing values and overwriting them. So, for example, if we wanted to change the grade in row 5 to an A, we could do it just like this. And now Jenny has a A2. All right. Another very important step in pre-processing data is handling NaN, or not a number of values. And they arise, for example, by creating new rows with only a single value, in which case the rest of the rows filled with NaN values. Let's do that. We are creating some new rows. And if we take a look at the data frame, oh, the fifth one already existed. If we take a look at the result, we can see that the row 6 has some NaN values, because we didn't specify those. We just entered the grade. And a very handy tool to look for those values is the isInA function, which returns true if the value is not a number. And in order to see the whole data frame, we can use it in conjunction with the sum function to see only the amount of NaNs in each column. Let's take a look. Yeah. As you can see, none is handled the same as NaN, as both are not really values, or both are missing values. We consider that. We can also delete or drop a row or column. This is done by using the function drop, which takes labels of the values that should be dropped. Say, for example, we wanted to drop the 6th row of our data frame. It's not that helpful. It's as easy as this. So you can see it returns only the first, or the data frame without the 6th row. But if we take a look at the data frame now, you can see that actually nothing has changed. And this is due to the function drop not being in place. It doesn't override the data frame at hand. You may alter this behavior by setting the keyword in place to true, and the function call. But there may be warnings that arise, as it's not encouraged. For better study, you can create a new data frame with the result of a drop function, like the one above. Like, instead of writing this, you would just create a new one and overwrite, instead of overwriting in the existing one. Anyway, we will certainly try it out. Oh, and there is no error or no warning message that arises in this case. Great. So we can just marks frame. See that it worked just in place. Right. There's also the very useful function drop_a, which you might have guessed drops rows or columns containing NaN values, and it takes exactly the same arguments. We don't want to do it in place. And as you can see, the sixth row within X5 was deleted as there was a none in the grade column. Yes. If we want to drop columns rather than rows, we have to specify the axis of the operation as the standard axis is 0, i.e. horizontal. Say that you'd like to drop the whole column. Great. You could do it like this. Just type axis 1. And then we don't have the grade column anymore. You could also do it using the columns keyword, and that results in the same data frame. There is also a function for dealing with duplicates too, eloquently named drop duplicates. As our data frame does not contain any duplicates, this should not really change anything. No. We could add 2 identical rows to the data frame and call the function again to see it in action, but I think you can imagine the outcome, and the video is long enough as is. That's it for part of the series, for this part of the series. In the next one, we will take a look at sorting, grouping, aggregating, data analysis, and plotting. See you then.